Salman, Khalid, can you send the okay. Can you send the assignment? Did you do the assignment, Salman and Khalid?
No, I was supposed to do after this class and then submit because tomorrow it's expiring. So
Okay.
I didn't do it.
Tomorrow it is expiring.
Yeah, 27th July. Yeah, I just saw it yesterday.
Achha. Why it is expiring on 27th July? Not
Yeah,
really
because it was posted yesterday. Yesterday, I believe. Yeah.
It was posted. Samira, it was posted yesterday. Huh, Samira?
So maybe 2 days before, I don't know. But not yesterday, it was before.
Not yesterday, right? Okay. So, Samira, what answer did you get? You're getting the same answer, Samira?
Yes, sir.
Why? Dekhiye. Acha, now you tell me. Did you look at some solution? Or you did it on your own? ये बताइए आप.
No, on my own only.
On your own only? पक्की बात?
Yes, sir.
पक्की बात? ठीक है. Like no help. All the questions.
Yes, sir.
Okay. So that means all of the questions, they must be done in our class, right?
Yes, sir. Some were there.
Okay. So look at the question number third, right? Third. Have you done this question? Have you done any reaction like that? Samira?
So that was in the textbook.
So that means you saw somewhere, right? Yes or no?
Yeah. Yes. Textbook and notebook help only.
Okay. So, your first question is right. Don't worry. I was just testing you guys. I just wanted to know, same with Hania also. Hania, you also gave the answer for the third one, in which we have done this CL, and they're asking about hydrolysis. So obviously this particular thing, hydrolysis, and we have not even mentioned hydrolysis. So I was wondering how you guys did this question. If I will react this with alcoholic KOH, we have only this carbon atom, and this is its adjacent carbon atom, which is having halogen. So it will be but1ene. Okay, chali, that's about the assignment. Let us move on to the part that we have to do today. And today we'll learn what are the conditions in which we can do nucleophilic substitution reaction for haloarenes. So you have seen there are two conditions, and we'll look at each of these conditions individually. So what are those two conditions, Salman? Tell me. Those two conditions in which haloarenes can show Sn. Yes, Salman. Salman, am I audible? Salman is not here. Okay. Khalid, tell me. Khalid, आप बताइए. What are those two conditions in which?
Haloarenes, right?
Sn for haloarenes. How can we do nucleophilic substitution reaction for haloarenes? Yeah.
Under drastic condition at high temperature and high pressure, and
Okay.
placing electro withdrawing at ortho or
Electron with
para. Sorry, electron giving.
इलेक्ट्रॉन विड्रॉइंग
At
सही बोला था आपने.
withdrawing, sorry, withdrawing at ortho or para position.
Okay. अच्छा, electrophilic substitution we have done, right? है ना? Yeah, we have done
Yes.
electrophilic substitution. Okay, okay. Now right here. The case one. See, at drastic condition, it is easy to understand. Please listen very carefully now. Okay, please listen very carefully. What are the two things that has hindered the reaction? We wanted to do this Cl, and we wanted to do some reaction in which we will have nucleophile, let us say, OH negative, and this OH negative should attack on this carbon atom. This particular bond should break, and this chlorine atom should leave. This should be done. So there are two things which were hindering. Please remember very carefully. There are two things. What are the two things? First thing was this bond was very strong. CX bond strong. Why was it strong? Due to partial double bond. Because it was partial double bond character due to resonance. That is why it was strong. And since it is strong, it is very difficult to break. So in order to resolve this problem, we added high temperature. Now at high temperature, what will be there? Each and every molecule, each and every atom in a molecule, it will be vibrating very intensely, okay, at high temperature, and the breaking of bond will be much easier, and the breaking of bond will be much easier. Okay. Now the next problem that we faced was this nucleophile was repelled by the benzene rings electron. Now it was repelled. Now in order to resolve this particular problem, what did we give? We gave high pressure. Now when we have high pressure, we are mechanically doing what? We are mechanically taking this OH negative and we are putting so much pressure that OH negative is bound to collide with the haloarene and it is bound to do the reaction. So in drastic condition, we have high temperature and high pressure. In that way, what does it do? It eases the reaction and it can show nucleophilic substitution. So there were two problems and we have resolved both those problems using high temperature and high pressure. Now let us see why the electron withdrawing group is so crucial here and why the electron withdrawing group is making the haloarenes do nucleophilic substitution, which they can't do at room temperature. Okay, so for that we have to first of all look at and what is so important about the ortho position and the para position we have, as we have by placing electron withdrawing group at ortho and para position. So for that you will write the case number 1. We will look at each case and we will look at electron withdrawing group. Please write with me. On.
So for drastic conditions, should we write anything?
No, for drastic condition you don't have to write.
Okay, sir.
Okay. Electron withdrawing group on. देखिए अभी एग्जाम में कभी पूछा नहीं जाएगा तो हमने बता दिया that you don't have to write it. Okay. But now whatever I am teaching, everything can come in examination. Okay, everything can come in examination. Case 1. Electron withdrawing group add on ortho position. On ortho position. Now, let us see. Just write the topic and then see here. Okay, don't write anything. Let us see what happens if I have a haloarene. We have bonds like this. Please listen, don't write. We have a halogen atom here and we have a NO2 group, that is an electron withdrawing group. Nitrogen with a double bond and a coordinate bond with oxygen. Okay, and there is a nucleophile which comes and attacks on this carbon atom, So first of all, what will happen? As soon as, अब देखिए बहुत ही ज़्यादा यहाँ पे important है, each and everything is very important. Now you see this carbon atom here, okay? And see why the organic chemistry is so interesting. This carbon atom, it has a bond with another carbon atom. It has a double bond with another carbon atom. It has a single bond with this halogen atom. Okay, this halogen atom. Now, what do you think is the most weakest bond? Which is the weakest bond here for this carbon atom, for this red carbon atom? Tell me, which is the weakest bond?
Carbon halogen bond.
Okay. Anyone else? Which is the weakest bond here? Think. There are 4 bonds. Consider each and every one. Consider each and every one and tell me which is the weakest bond. Yes, Samira, tell me which is the weakest bond.
The carbon-carbon bonds.
कार्बन कार्बन कौन सा? दो कार्बन कार्बन बॉन्ड है, एक बात बताइए. देयर आर लाइक
Single bond, sir. Single carbon, carbon, single bond.
अच्छा, ओके. मीनाक्षी, टेल मी which is the weakest bond. There are 4 bonds here. अब हम बताएंगे तो फिर आप लोग को. There is CX bond. Wait a second. There is CX sigma bond. There is CC sigma bond. There is CC sigma bond, and there is CC pi bond. Which one is easiest to break? Which one is easiest to break? Minashi is saying carbon and
Halogen.
halogen. Okay. Tell me, Nabil, आप बताइए. What do you think, Nabil Khan? Which bond is easiest to break? Which is the weakest bond?
Single carbon carbon.
Carbon carbon. Okay. Matthew, what do you think? Which is the weakest bond?
CC sigma.
Okay. Khalid, what do you think?
Carbon carbon bond.
Which carbon carbon? Sigma or pi?
Sigma.
Sigma. Okay. Nawal ने answer किया. Nawal, tell me.
Sigma carbon bond.
Okay. Saif, you tell me.
I guess CX bond.
CX bond. Okay. Chemical bonding किसी का ठीक नहीं है. All of you have forgotten chemical bonding.
Pi
एक तो जो
bond,
मेरे
right?
which bond?
5 bond.
कार्बन कार्बन पाई बॉन्ड ना भाई लोग हैं. क्या हो गया आप लोगों को? पूरा भूल गया क्या? कार्बन कार्बन पाई बॉन्ड. What type of overlapping is there in carbon carbon pi bond? It is parallel overlapping. ऐसे रहते हैं pi bond. It is easier to break. Sigma bond is head on overlapping, right? It is difficult to break. भूल गए सब? Does it make sense? Which is the weakest bond here? Carbon carbon
Yes,
pi
sir.
bond. Yes or no? Make sense? Okay. See, that is why organic chemistry is interesting if you know the basics. If you forget the basics, it is becoming याद करना पड़ता है. Organic chemistry में भी याद करना पड़ता है. रटते रहो बस equations. No, it's not like that. Now what is going to happen? This pi bond is going to break. अब देखिए, each and everything, if you boil it down, if you look at a reaction, now this carbon has a pi bond like this. Now when this pi bond is breaking, either it will go to this carbon atom, the electrons will go to this carbon atom or this carbon atom. Now there is a question, which carbon atom? So you will see that this carbon atom is already getting a nucleophile, right? This carbon atom is already getting a nucleophile. It is going to make a 5th bond. That is why it will break a bond and it will transfer the electron to the adjacent carbon atom. Okay, so this bond will break and we will get a negative charge here. Okay, so we'll write that. Have a nitro group, double bond O, single bond O, and here we have an X atom which was already present, and then we have nucleophile. Here we have nucleophile, and here we have a negative charge. These pi bonds are as it is. See how simple is this? Now let us see what is the nitro group doing here. What is the nitro group doing here? Okay, so the nitro group here, it is adjacent, it is just attached on the carbon atom which is having the negative charge. So what will it do? This negative charge, we'll see that, okay, fine, we have resonance A, double bond B, single bond C with a negative charge. So the electron transfer will take place like this. This negative charge will go on to this bond here. It will form a pi bond, and this pi bond will break and it will form a negative charge. So you can write a resonating structure like this, in which is making a double bond with nitrogen. Nitrogen making a single bond with oxygen. This oxygen gets a negative charge, and there is already a dative bond with oxygen of nitrogen. Okay, and here we have nucleophile and X as it is. And these pi bonds are as it is. Now, as you can see, this negative charge is delocalized, and this nitro group is attached on that carbon atom, which is getting the negative charge. That is why what will happen here, this negative charge will be stabilized, because negative charge is going away from the, ring. That is why this negative charge is stabilized. Now let us look at the second case, that is case 2, meta position, case 2. Just listen, don't write. Electron withdrawing group on meta position. Now we will have the same thing. We'll have the same haloarene. We will have the X group here, the halogen atom, but the nitro group will be on the meta position. Double bond O and a dative bond with oxygen. Again, the nucleophile will come. Similarly, it will attack here, And what is going to happen? This pi bond is going to break and it will transfer the electron onto this carbon atom, which will lead to a carbon ion formed. Here we'll have the X and here we'll have the nucleophile. And here we have the negative charge. This nitro group is as it is, nothing has happened here till now. And there is a dative bond with oxygen. These pi bonds are as it is, there's nothing changed there. Now we see a condition for resonance that is being fulfilled. A with a double bond B, single bond C, and C has a negative charge. Now this negative charge is going to go here, form a pi bond, and this pi bond is going to go here and make a negative charge. And we will see a resonating structure like this. There is a pi, there's a nucleophile and X. Nitro group is as it is, nothing is, nitro group is not doing anything, as you can see here, right? And there is a pi bond here, there is a pi bond here, and there is a negative charge here. Okay. Now here you can see nitro group has already been passed. Nitro group ne kuch nahi kiya. So the carbon atom, the nitrogen group, the nitro group, it is not attached on that carbon which has the negative charge. That is why on meta position it has no role. On meta position it has no role. Now let us look at the last case. Case 3. Listen, don't write. I hope all of you can see that nitro has no role in the meta position. Please tell me yes or no.
Yes.
हाँ guys, समझ में तो आया ना? Okay, yeah. Just listen. Electron withdrawing group at para position. If I look at the para position, then what it is going to be, we will have the same haloarene. Pi, pi, pi. Here we'll have the X. And on the para position, I will have nitro with a double bond oxygen with a dative bond of oxygen. And there will be a nucleophile as it is. It will come, it will attack here. And we are going to get this particular pi bond will break, it will go here. And then we are going to get nucleophile and X. The negative charge will be here. And these pi bonds are as it is, nothing has happened here. And this is nitro group, which is here. Double bond O and double bond O. Now again, this A double bond B, single bond C, and C has a negative charge. So there is a condition of resonance which has been fulfilled. Now, these electrons, these negative charge, it will form a pi bond here. This pi bond will form a negative charge on this carbon atom. And we will get a resonating structure which will look something like this. Nucleophile and X. And here we have a pi bond, here we have a pi bond. We have a pi bond. Here we have a negative charge, and this negative charge is on that carbon atom which is containing the nitro group. Now, further nitro group is going to do what? Nitro group will say that, okay, fine. Negative charge, please come to me because we have A double bond B, single bond C, A double bond B, single bond C, and C with a negative charge. So this negative charge will come down towards the nitro group. And here also the nitro group is playing some role. It is doing what? It is taking up the electron from the benzene ring. And thus it is stabilizing the intermediate that we are having. You'll get the double bond here with the nitrogen, and this electron will go towards oxygen, making a single bond and having the dative bond. Okay, so we will be getting a bit of charge. So see, in the para position, the nitro group is playing some role. In meta position, it is not playing any role. In ortho position, also it is playing some role. That is why we place the electron withdrawing group on the ortho position so that it will ease up. Because we are making an intermediate, this intermediate should be stable. And this intermediate can only be stable if we have the electron withdrawing group at ortho position or the para position or the para position. Meta position has no role. Okay, so please now write these 3 cases. Let me know if you have any doubt while writing. I will explain it once again. But first of all, please write this down.
Sir, can you show the topic once?
Nothing. Yeah. We have, what is the last thing that you have written? By placing electron withdrawing group at ortho and para positions, right? And then you will write case 1. Electron withdrawing group on ortho position.
Okay, sir.
Those who have joined late and those who have not done haloalkane haloarenes preparation part, I hope they are watching the videos. Please let me know if you have any doubts. Also, in the meanwhile, once you are done with haloalkane haloarene, you should be watching the lectures of solutions and coming up with doubts if you have any. This is especially for Nabil Ahmed, Nabil Khan. You guys have joined late, right? Yes or no?
Sir,
Yes.
Yes, sir.
है ना? So preparation कर लिया आप लोगों ने Haloalkane, Haloarene. Did you watch the lectures?
watching, sir.
No. Watching.
Some of them,
कितना हो
sir.
गया? कितना हो गया? Today is the last class Haloalkane, Haloarene का. Next class will be only conversions. There are 30 conversion. एक class में 30 conversion करा देंगे. And then उसके बाद next class से आपका alcohol phenol ethers. कुछ अगर छूट गया तो छूटा रह जाएगा, प्लीज याद रखिए, ठीक है? और फिर छूटता चला जाएगा. एक दिन बैठिए, सब कंप्लीट कर लीजिए सारा, एटलीस्ट लिख लीजिए. नहीं समझ में आ रहा है, लिख लीजिए. देन स्लोली यू रीड इट अपॉन, रिवाइज करते जाइए, समझ में आती जाएंगी चीजें.
Inshallah, sir.
ठीक है, तो नेक्स्ट क्लास जब हम करेंगे ना, तो यू हैव टुमारो वेडनेसडे, राइट? सो कल आप सारा खत्म कर दीजिए. प्रिपरेशन ज्यादा है भी नहीं वैसे, 2-3 लेक्चर्स होंगे हमको लगता है. प्रिपरेशन खत्म कर दीजिए, दैट इज इट. उसके बाद आई थिंक केमिकल प्रॉपर्टी से आपने पढ़ा ही था हमारे साथ. एंड जब हम थर्सडे को पूछे कि कितना वीडियो देख लिया आप लोगों ने, तो फिर आप लोगों का जवाब आना चाहिए सर सारा देख लिया, पूरा हालोअल्कीन हो गया खत्म. अब सर आप कन्वर्जन करा दीजिए बस, है ना? और कन्वर्जन के लिए तो जरूरी है, you have to know all the reactions, at least in paper you should have all the reaction in one paper. In one paper in मतलब preparation of haloalkane in one paper, preparation of haloarene in one paper, chemical properties of haloalkane in another paper, chemical properties of haloarene in another paper. So you should have at least these 4 sheets, then only you will be very much comfortable with the conversions जो हम कल कराने वाले. कल means Thursday for you guys. Okay. Done everyone? Yes, no, please tell me.
No, sir.
लिखिए आराम से लिखिए. Write it fast, write it fast. Raise your hand when you are done, please. Raise your hand when you are done. Samaira, Nawal are done. Very good. Minashi is done. So I think all of you must have done till 2. Salman is still writing. Salman, Khalid, Ishma,
Done.
Yes,
done.
sir.
Done. Ishma is writing. Okay, waiting for Nabil Khan and Hishma, I guess. Okay, others you can lower your hand. Just a second, no?
Done, sir.
Okay. So I hope everyone is done now. Now let us write the points that we have just seen. Right, the first point. When electron withdrawing group is placed at ortho and para position, placed at ortho and para position, then the negative charge appears on that carbon which contains the electron withdrawing group, which contains the electron withdrawing group. Hence, the intermediate is stable. Hence, the intermediate is stable. Write the next point. When electron
Sir, could you
withdrawing
show
group,
the heading again?
यहाँ कोई हेडिंग नहीं है, यही तो
Okay.
यही लिख रहे हैं ना, अभी जो हम लोगों ने ड्रॉ किया उसका कंक्लूजन लिख रहे हैं बस, है ना? What I have explained, I am writing that down. You have to write this down. Okay, please write this down. When electron withdrawing group is at meta position, then the negative charge does not appear on the carbon containing electron withdrawing group. Hence, the intermediate is not stabilized. Okay. So write the concluding point. Sn of haloarene is possible when electron withdrawing group is at ortho or para position. Right, Sn of haloarene. It can be either done at room temperature or at drastic condition or in the presence of electron withdrawing. So when it is done at room, it can be done at room temperature, can be done at drastic condition. It can be done with the presence of electron withdrawing group. So when it is done at room temperature, it is possible. No, it is not possible. My bad. It is not possible at room temperature. In drastic condition, it is possible. For electron withdrawing group, we further have three categories, right? It can be either on ortho, or it can be on para, or it can be on meta. So if it is present in ortho, then it is possible. Para, it is possible. Meta, it is not possible. This is the conclusion that we have drawn from the discussion above. Sn of haloarene, it is possible at drastic condition or when the electron withdrawing group is present at ortho or para position. Write this down, then we will write the reactions. So the first reaction, we have here of chlorine. We have here a haloarene. We are reacting this with aqueous NaOH or aqueous KOH, let us say. Now we need drastic condition because we don't have any electron withdrawing group. So the drastic condition is there are 6 carbons. उसी तरह याद रखिएगा, there will be 6 2 3. 6 carbons, 3 pi bonds, 6 to 3 Kelvin. And यहाँ पे 3 से end किया 300 atm pressure. 300 atm pressure. Now think about, there is some pressure that you are feeling right now. Okay, 300 times of that pressure. So it is going to be very huge pressure. And that is why you are going to get what? This chlorine bond will be broken. And you will get a phenol.
This is an example, sir.
Or what do you think what it is? Tell me. Huh? What do you think what it is? Nabil, you asked the question, no? Nabil ne pucha tha na? Nabil or Saif? Who was that? I could not get it.
Sir, it wasn't me.
Achha. Nabil Ahmed, was that you? There are two Nabil.
No, sir. Not me.
Not you.
Me, sir.
Saif, you are. हाँ नहीं, you tell me what do you think what it is? क्या लग रहा है? अरे बोलिए तो क्या लग रहा है?
I don't know, like something.
You don't know? What is the topic? What is the topic that we are learning?
Sn of haloarenes.
Okay, so Sn of haloarene. अब ये बताइए, have you seen this reagent anywhere else? Have you seen aqueous NaOH anywhere else in this chapter? Saif?
I guess it is in haloalkanes.
हाँ, haloalkane तो एक पूरा टॉपिक. haloalkane में कहाँ देखा है आपने? In which subtopic of haloalkane? ठीक है, तो रिवाइज कीजिए सर. ओके, सो दिस इज अ न्यूक्लियोफाइल हियर. यहाँ पे आपके पास आपको ध्यान होगा अगर हम यहाँ पे बताएंगे कि दिस NaOH will have what? It will have Na plus, है ना? And it will have OH negative, right? OH negative is electron rich. That is why it will be what? It will be nucleophile. Yes or no? And this is going to attack. याद आया कि नहीं याद आया? सर
Yes, sir.
रिवाइज कीजिए. पता चल रहा है? बिल्कुल रिवाइज नहीं कर रहे हैं आप लोग? Write the subsequent reactions now. If I will have the same haloarene, but we add just here NO2 group in the ortho position, I will have aqueous NaOH. Now, just in the presence of some heat, it is going to give me OH and nitro group. Plus NaCl will be the byproduct. Now here, this is phenol. This whole thing is phenol, and we have, this is the first carbon, second carbon. The first carbon is labeled as per the basic name, that is phenol. So this will be what? 2 nitro phenol. Similarly, if you have chlorine, NO2 and NO2 in the para position also, plus aqueous NaOH. And just in presence of a bit of heat, lesser than the earlier case, you will get OH, NO2 in the ortho, NO2 in the para as it is, and subsequently you will get NaCl. I'm not writing here, I'm just writing, this is what? 1, 2, 3, and 4. So 2, 4, dinitro phenol. Now, if you have chlorine with 3 NO2 groups, 2 in the ortho and 1 in the para, you react this with aqueous NaOH or KOH at room temperature only. It's going to give you nucleophilic substitution, producing a phenol which has nitro groups in the ortho and para positions. This is 2, 4, 6 trinitro phenol. It is also known as picric acid. Chale.
Sir, what did you write again? Pyric acid?
Picric, picric. PICRIC. PICRIC, picric acid. Done everyone? Yes or no? Please tell me. Done everyone? Yes or no? Please tell me.
Yes, sir.
लिख लिया सबने? Okay, fine.
1 minute, sir.
Okay, okay.
Yes, sir, done.
Done. Okay. Our next topic is optical isomers. Okay. Our next topic is optical isomers. But to understand optical isomer, you have to first understand some terminologies. And the most important terminology here is plane polarized light, PPL, and that we call it. Plane polarized light. Acha. How many of you have used sunglasses? All of you must have used sunglasses. Yes or no? Please tell me. The shades, sunglasses, yes or no?
Yes, sir.
Yes, all of you have used. Now, that sunglass, what it is doing, it is getting some light into it. Okay, it is getting some light into it, and it is producing not only some light, it is getting many lights, right? Many wavelength of light, and it is what it is doing, it is producing only one kind of light as a result. After it passes through the glass here, what it gets polarized. Polarized means it gets the wavelength will be in only one direction. For an example, let me show you something. How this works. Yeah, can you see this? Can all of you see this light wave? Yes or no?
Yes, sir.
Okay, now see. The first grid that we have here. Okay, now wait a second. Let me stop this because I need the annotation tool. I don't have the annotation tool right now. Still, I don't have the annotation tool. Sometimes this gets quite weird. I don't know what is the reason. Sometimes I get that annotation tool with which I can write things, but I don't think it is there right now. Okay. Stop sharing.
So maybe the boost is not having the permission.
No. For example, if I stop sharing, share this screen of whiteboard, here I can write things. But let me see. Start a new share from here. Now it is gone. Fair. I may have a plugin. Let me see somewhere here.
You can access the annotation too, right? Like on the screen share settings, no?
I don't know. I have not like it. It is variable, very. Can you see my cursor? Let us see that. Can all of you see my cursor?
Yes.
Yes.
Yeah.
Okay, fine. So the first wire grid, it is what? It is vertical, right? It is vertical. That means it is stopping all the wavelength, all the light waves which are vertical direct. So it is just what it is doing. It is passing the ones which are horizontal. Everything else, it is getting what? Everything else is getting obstructed on the first grid, on the first wire grid. Okay. Now let us see what is going to happen. Now, if I change the direction of this second grid, can you see the waves also changing? Yes or no? Tell me. Can you see the direction of
Yes.
wave has changed?
Yes,
Now
sir.
I think it is maybe you can see now, right? I don't know what is a better view, but you can see that it has changed. Now slowly, if I increase this, the angle by which it is changing, see, it was completely the waves that were completely horizontal, and they're slowly getting vertical, right? And then it stops. Why? Because now what is happening? The first grid, which is vertically oriented, it is stopping each and everything, and it is just letting pass the horizontal ones. The second grid is horizontally oriented, and it is doing what? It is just letting pass the light waves which are it will just let the light waves which are vertical. Now there is no vertical light here because it has been obstructed by the first wire grid. That is why we don't see any light wave coming. So this is known as polarization. So these are polarizers. The like simplest example of a very common polarizer is your glass shades. Okay, it is the glass sheets. Now let us write about optical isomers. What does optical isomer have to do with this? So please write with me. Please write with me. The isomer which rotates, the isomer which rotates, the isomer which rotates plane polarized light we will call this as PPL further on. Okay, plane polarized light in clockwise or anti-clockwise direction is called optical isomer. And the compound is known as, and the compound is called optically active compound. Optically active compound. So the white light that we see, it consists of all the wavelengths, and that is why it consists of, there will be light waves which will be vertical, horizontal, in this direction. In each and every direction, the white light will have light of different colors in different direction everywhere. And this is known as unpolarized light. Unpolarized light. Now, we use something like Nicole prism, which polarizes it. That means it lets the light of any single direction pass through it. Right? So we represent Nicole prism in this manner. This is Nicole prism. And what will it do? It will let the light of any one direction pass through it. So here we'll be getting any one light. Let us say we got this vertical one. Now, when this vertical one, and this vertical one is passed through an organic solution, Now, if this organic solution will contain some optical isomer, some substance, some molecule which is optically active, then it is going to either rotate it in the clockwise direction or it will rotate it into the anti-clockwise direction. If we see any movement or any change in the direction of polarized light, this is unpolarized and this is polarized. This is polarized light. And specifically, it is a plane polarized light. It is polarized in one plane. There are not different planes. This is also PPL. Okay. And what it has done, it has either rotated it clockwise or anti-clockwise. Both can be present. Now there are names. Let me draw it properly. There is no option to rotate this thing. Rotate horizontally. So it can either rotate it clockwise or anti-clockwise. Our initial plane polarized light was somewhere here. Our initial plane polarized light was somewhere here. And we can see that there is a change of some angle here. You can call it as theta, or it is also known as alpha. It's also some theta and or alpha. Now, this is anti-clockwise. Anti-clockwise. and this is in the clockwise direction. Okay, so if it rotates it anti-clockwise, then it is known as levorotatory. L-A-E-V-O, rotatory. Also known as the L form, or also known as the minus form. This is known as, if it rotates clockwise, then it is known as what? It is known as dextrorotatory. Okay, and it is known as the D form, or the L, sorry, or the plus form. Okay, so I'll write these points, but first of all, आप लोग ये सब लिख लीजिए अपना. From unpolarized light, it passes through the Nicol prism. It will give you plane polarized light, and if the plane polarized light passes through organic solvent, this is my organic solution, organic solution. Let me know when you're done.
Done, sir.
Sir, can you please spell the levorotatory something? Anti-clockwise second name.
Levorotatory. L-A-E-V-O-R-O-T-A-T-O-R-Y. L-A-E-V-O. After that, it is rotatory. Levorotatory. Okay, I will write this down.
Yeah, okay, sir.
So if organic solvent, this is my organic solvent, rotates the light, which light? Plane polarized light, in clockwise direction, then it is what? It is dextrorotatory, or we call this as D form, or we call this as plus form. That organic solvent is known as, that organic solvent will be, we will say that it is dextrorotatory solvent or dextrorotatory solution, dextrorotatory compound. Secondly, if it is anti-clockwise, direction, then it is levorotatory or L form, or the negative form. Okay. Now, how to identify whether an organic solution or whether a molecule is optically isomer or not, it is optically active or not, then there is a concept which is known as asymmetric carbon. Write about this. Asymmetric carbon. Easy definition, please write this. Asymmetric
7 minutes.
carbon. Okay. Done? Yes or no?
No, 1 minute.
See, again, I will suggest these are the things that we have already written. Okay. So try not to see the screen and write it on your own. Anti-clockwise, खुद से आप ध्यान रख करके लिखिए कि laboratory or L form or a minus form. When you're writing the stuff that has been already explained, try to not look at the screen. In that way, you will not be requiring revision for many times.
Yes, sir. Done.
अभी अगर याद कर लीजिएगा. Okay. Asymmetric carbon. What is asymmetric carbon? Please write with me. The carbon which contains the carbon which has 4 different groups attached to it is called asymmetric carbon. Okay. Asymmetric carbon. For example, you have a carbon atom which has a OH group, same carbon atom has Br group, same carbon atom has a hydrogen, and same carbon has a CH3. So this carbon here is asymmetric. This carbon here is asymmetric. And we show that asymmetric carbon by this star sign. If they ask you label the asymmetric carbon, then you will put the star sign on that carbon atom, which is asymmetric. Okay, so you can see that it is having a CH3 group, OH, Br, and hydrogen. So this is what? This is a asymmetric carbon. The last terminology that you have to remember is chiral molecule. What is a chiral molecule? Please write this with me. The molecule which is not
Sir, can you say what you just wrote on subheading?
chiral molecule. CHIRAL, chiral molecule. The molecule which is not superimposable, on its mirror image is called chiral molecule. Is called chiral molecule. For example, you see here if I write A. Okay, so I've written A here, and if I look at the mirror, if I have a mirror like this, okay, now what I will see, in the mirror I will see the same thing, right? Yes or no?
Yeah.
Right, I will see the same thing even if I rotate, but I don't think I can rotate it now. Are there option? Are there option? Okay, fine. If I rotate this thing, then I will get what? The same A. But if I have, let us suppose B. Okay, I have this B here, and I want to see this in the mirror. Then in the mirror, it will look something like this. Yes or no?
Yes, sir.
Okay,
Yes,
so
sir.
anything. So chiral means handedness actually. Chiral का literal meaning क्या होता है? It is handedness. Now, if you look at your hands, they are both what? They are mirror images of each other. Yes or no? You have to put it like this. Your hand like this. This is your pinky maybe. Right, small. I hope it has 5 fingers now. 1, 2, 3, 4, 5. Yeah. So, now your hands are not like this, correct? Your hands are like this, correct? Yes or no? If you put them on front, so there are mirror images of each other. Can all of you see that? Yes or no? Please tell me.
Yes, sir.
There are mirror images of each other. Now, if I take this hand like this, and I want to, let me write this as red color, okay? And I want to superimpose it on this hand. Can you see that it is not superimposable? Yes or no? Can all of you see that?
Yes, sir.
The fingers are fine, but the pinky is not aligning with the pinky and the thumb is not aligning with the thumb. Yes or no? So this is known as, this is handedness. Anything which is handed. So our letter A is not handed, it is not chiral. This is not, oops, keep it red. And let me also paste this here. Yeah. So my A is not chiral. That means it is superimposable. And a chiral molecule will be not superimposable. What is B? B is chiral. And what is our hand? Hand is also chiral. Okay, hand is also chiral. Now it is superimposable because we have a symmetry here. A is symmetrical, and on the axis which we are showing the mirror. But B here is not symmetrical, right? B here is not symmetrical. Similarly, our hand, we are showing it like this. It is not symmetrical in this manner. So that is why anything which will not have symmetry, if anything is asymmetrical, it is going to be what? It is going to be chiral. It is going to be chiral. Now, I hope you have written this. No
Yes,
need
sir.
to draw the hand, okay? Just draw A and B, that will be fine. Now, write the next point. It's an important point. Condition for optical isomer. Okay, so right here, the necessary and sufficient condition for optical isomer is that a compound should not be superimposable on its mirror image. That is the only condition that you have to follow. Okay, that is the only condition that you have to follow. But we can't always make a mirror image and then see whether it is superimposable or it is not superimposable, right? So there are some things that you can do. And in your standard, it is like in 12th standard, the CBSE part, it is very easy. You will get only one case. Write this down, the condition, then we'll look at the case. Done everyone, yes or no? Please tell me. Condition for optical isomer.
No, sir.
No, sir.
Done, sir.
What about others? Is there anyone who's still writing?
Answer.
Done, sir.
Done.
Okay. Right. See, if there is a molecule and if you find any asymmetric carbon, we have asymmetric carbon. Okay. Now, if a molecule contains only one asymmetric carbon, only one asymmetric carbon, okay, then it is always optically active. Okay, it will be always, and this is the only thing that you will be asked in CBSE. आपको बस ये देखना है कि एक है कि नहीं. They will not ask you any other case, but still, right here, if you have two, if you have two asymmetric carbon, now in two asymmetric carbon there can be two cases. If the asymmetric carbon, they have same groups, if they have same group, this may or may not be chiral. Okay, this may or may not be optically active. But if they have different groups, then this is going to be always optically active if they are different groups. But if they are same groups, then it is not going to be optically active. Okay, but you have to remember one case. अच्छा, 3 cases आप लोग सबको समझ में आ गए. This is the most important case. Okay, जो हम यहाँ पे स्टार मार्क कर रहे हैं, इस पे आप लोग ज्यादा फोकस कीजिएगा. If it has any asymmetric carbon, now the skill that you have to develop, now ये तो flowchart आ गया आपके पास, right? If you have found asymmetric carbon, then you will refer to this flowchart. So this flowchart is not the skill. What is the skill? The skill is to identify the asymmetric carbon. Identify the asymmetric carbon, and we will do questions on that now. We'll do the questions on that. Now, write this down. Let me know when you are done. Write this flowchart. Let me know when you are done. Okay, Salman is done. Only one asymmetric carbon, always optically active. If there are two asymmetric, okay, fine. Everyone is done. Okay. Let us take a simple example like this. Okay, now please listen, don't write. Leave your pen aside. Okay, leave your pen aside. They will, if they give you some questions like this, for example, they will give you a question and they will ask whether is this optically active. They will ask, is this optically active? Or they will give you a pair of molecules. That means they will give you two compounds and they will ask which one of them is optically active. Now, the easiest thing that they can give is you have carbon and you have 4 groups like this, and they will give you such as hydrogen, CH3, OH, and Br. Okay, and if you have only one carbon here, they have given you very easily here. Now you tell me, is this carbon here optically active? Is this asymmetric? Yes or no? Tell me here.
Yes, sir.
Is this asymmetric? Then you will get the answer. Yes, this is asymmetric. And then they will ask, then you will ask yourself, they will not ask, you will ask yourself, we have only one carbon, right? And this carbon is what? It is not asymmetric because it is having 3 hydrogens. Tell me yes or no. This, what about this carbon? Is it asymmetric? This carbon here?
No, sir.
No, it is not asymmetric. That means we have only one carbon which is asymmetric. That is why this will be what? It will be optically active. समझ में आ रही है बात सबको? Yes or no? Please tell me. Nawal, Minashi, Hishma, Samaira. Yes? Okay. Fine. Now, but this is the easiest case that they can give. Now, complicate करने के लिए आपको पता है कैसे देंगे? They will give you something like this. ऐसे दे देंगे आपको. Now, the first thing is, देखिए क्या क्या चीज यहाँ पर टेस्ट हो जाता है. And why organic chemistry becomes difficult? Because this is the first chapter हम ये बता रहे हैं आप लोगों को. First thing that you should know is how the bond line structure. If you don't know the bond line structure, if you don't know the number of hydrogens on each carbon atom, तब ये आराम से गलत हो जाएगा आपको, right? This will be, आप लोग गलत करके आइएगा. The first thing that you have to understand is the number of hydrogen on each carbon atom. So we will look at the number of carbon on each hydrogen atom. Tell me 1, 2, 3, 4, and 5. We have 5 carbon atoms. अगर इन पांचों को हम लोग देख लेंगे, we will look individually at all of these 5, and then we will see that okay, fine, which one is going to have, if is there any carbon which is asymmetric, वो हम लोग देखेंगे. For that we have to look at hydrogens. So tell me the first one, how many hydrogens? The first one will contain how many hydrogens?
3 hydrogens.
3,
Second will contain how many hydrogens?
2.
2,
2. The third one will contain how many hydrogens?
1,
1. Fourth one will contain how many hydrogens?
2,
2. And fifth one will contain how many?
3.
3. So obviously we can see that I can eliminate these carbon atoms, the 1, the 2nd, the 4th, and the 5th, because they already have multiple hydrogens. And if they have if any two groups, if the groups are same, then it is not going to be asymmetric. Now we have to look at this carbon atom, that is the third one. You have to look at this carbon atom. This is the third one, which is having 1 hydrogen atom. Now raise your hand if you think it is asymmetric. Raise your hand if you think it is asymmetric. देख के बताइए. Okay. Raise your hand if you think it is symmetric. If you think it is not optically active, raise your hand. Okay, I've got some answers. Okay, I've got some answers. Huh. So all of you are telling me that it is not optically active. Okay, I see some people, they are not raising hand in any case. Hania, tell me, what do you think? Hania,
Yes, sir.
what do you think? Is this optically active, not active?
It's not.
Why? Why is it not? Tell me. You have to look at the groups. Now tell me this carbon atom. Anya, keep your mic on. This carbon atom. What are the groups on this carbon atom? Tell me. What are the groups attached or the atoms attached on this carbon atom? Tell me.
OH.
OH is attached. And then what is attached?
Hydrogen.
Hydrogen. And third one is, tell me what is attached.
Carbons.
तो क्या ग्रुप कौन सा है वो बताइए आप. What is that group? How many carbons are attached? Tell me, Hania.
2.
2 carbons. Okay. What is the word for 2 carbons in organic chemistry? What is the word for 2 carbons in organic chemistry? Eth, meth, prop, but, hex, hept में क्या है?
Eth.
Eth. Okay. So and this is what it is, an alkyl group. So we will write it as what? Ethyl. Okay. So I am writing this one as ethyl. Okay, which will be C2H5. Correct. And what is the
Yes.
fourth group? What is the fourth group? This one.
Ethyl.
This is also ethyl. आप ऐसे इतना घबरा के क्यों बोल रही हैं? C2H5. Okay. So I hope बाकी सबका भी आंसर यही होगा, because we have 2 ethyl groups attached on this carbon atom. That is why it is not asymmetric. Is this clear with everyone? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Right. Okay. Now if I have something like this, please see. Okay. If I have a OH group here. Now tell me, is this optically active or inactive? Raise your hand if you think it is optically inactive. Optically inactive. Raise your hand if you think it is also optically inactive. आप लोगों को अब ये पता लग गया होगा that if a carbon is having no groups attached, then it is going to have at least 2 hydrogens. So this will be 3 hydrogen. This will be 2 hydrogen. This will be 1 hydrogen, this will be 3 hydrogen. So the only carbon that you have to look at is this carbon atom. Optically inactive. Okay, Nabil Khan and Nabil Ahmed. What are the groups attached? Tell me.
To the third
Hydrogen, OH.
hydrogen,
Hydrogen.
OH, methyl and ethyl.
So optically active होगा ना, inactive तो नहीं होगा. Asymmetric carbon हो गया ना,
Yes,
Yes.
sir.
है ना? तो फिर आप लोग हाथ रेस करके क्यों थे? C2H5. बाकियों का समझ में आया? हानिया, did you get this one? This will be asymmetric.
Yes,
It will be chiral. It will be optically active. Optically active. Okay. चलिए. Right for this one. Tell me in chat. Optically active, optically inactive, can't say. Optically active, optically inactive, or can't say. This particular molecule, okay, this molecule is what? Optically active, inactive, or can't say. Okay, Samaira. Correct answer, very good. Okay, Salman, okay, Salman. Okay, Nawal, okay, Nabil Ahmed. Hania, correct. Salman, correct. Samaira, correct. Wait, भाई साहब, ये तो ऐसा लग रहा है वो स्ट्रीमर्स के चैट्स होते हैं ना, अब तो आंसर वैसे आ रहे हैं बिल्कुल फास्ट. वेट अ सेकंड. मैथ्यू, ओके. Nabil, okay. Minashi, okay, fine. Nabil Khan, can you tell me what are the groups attached? Saif, okay. Nabil Khan, can you tell me what are the groups attached? Nabil Khan, turn your mic on and tell me. Yes, Nabil Khan. सबसे पहले let us choose the carbon. बताइए कौन सा कार्बन चूज करें? नबील खान, turn the mic on, turn the mic on. अरे what happened? You can't turn the mic on. अभी तो बात कर रहे थे आप, क्या हो गया? Okay. Matthew, what about you? Can you turn the mic on?
Yes, sir.
Okay, to which of the carbon you are choosing? Tell me.
3.
Third carbon, which will be having 1 hydrogen. So tell me what are the groups attached?
Cl,
Cl,
and H.
hydrogen, okay.
Yeah. Then there is ethyl. There's a ethyl group.
C2H5 and
Yeah. And methyl group.
so 4 different ना, asymmetric
Yes.
carbon, only 1. तो optically active होगा ना? What you have written? Matthew, see what you have written.
Yes, sir. I understood my mistake.
Understood.
I think. Yeah.
ठीक है, चलिए. So I think you must not have written all of these above questions. Maybe. I hope it is visible now. Right. You can zoom it a bit more. Okay, that's enough. Yeah. 1, 2, 3, 4 questions you have done. Not many questions are there in NCERT. Now, 3 more things, then we will be done. Okay, 3 more things. So आज थोड़ा सा class लंबा जाएगा, but don't worry, the chapter is completed now. We will do conversions. Conversions हम कल इसी वजह से कराएंगे Thursday को. Please, all of you, please come, and all of you, please have the 4 things for the next class. You will have reaction maps. Of preparation of haloalkane, preparation of haloarene, chemical properties of Rx, haloalkane, chemical properties of haloarene. you should have at least these 4 pages. Then only you will be comfortable with the reaction that I will be writing tomorrow. Okay. There are 30 conversions in this chapter. 30. Out of which 2 questions are repeated. I don't know why. Okay. 2 questions are repeated. So uniquely, we have 28 conversions. There are 28 unique conversions in NCERT. We'll be doing all of those 28. We'll be doing all of those 28. Done, everyone? Yes or no? Please tell me.
Yes, sir.
Okay. Now write next. Now, just now what we saw here, na? This B and B, these are what? These are not superimposable mirror images, right? These are not superimposable mirror images. So we have a word for this in chemistry. We call them enantiomers. है ना? जैसे cousin होते हैं. So cousin is a relationship. Similarly, we have enantiomers. Enantiomer में क्या relationship है? Enantiomers are what? They are non-superimposable mirror images. है ना? Please remember this definition as it is. Non-superimposable mirror images. Okay. Please write enantiomers. Okay, right. Enantiomers are non-superimposable mirror images. Non-superimposable mirror images. They always exist in pairs. है ना? अकेले कोई तो mirror image हो नहीं सकता ना. There should be 2. Always enantiomer will be in pairs. What is the property for enantiomers? They have same molecular formula. But property क्या different है? But rotate the plane polarized light in opposite direction. In opposite direction. Okay. So for example, if you have carbon with hydrogen, bromine, CS3, and let us say OH. And here we'll have hydrogen, carbon, bromine, CS3 and OH. These are non-superimposable. And what is the relationship between these two? These are enantiomers. Okay. Now, which one will rotate anti-clockwise and which one will rotate clockwise? We don't. But we know that one of this will, if this rotates clockwise, then this is going to rotate anti-clockwise. Okay. So these are like a couple or pair. If one rotates clockwise, the other will rotate anti-clockwise. That is the only difference. And they will also rotate the plane polarized light in the same angle. The angle will be same, but the direction will be completely opposite. Direction will be completely opposite. Done with the point. Last point also done. Not done. Let me know if you're writing. If you're done, then you will write the next point, that is racemic mixture. Now, when the enantiomers are present in equimolar concentration, that means we have a solution in which 50% is of one isomer and 50% is of another isomer. That means we have 50% this and 50% this. Then that is known as racemic mixture. Okay, so please write the equimolar mixture of D and L form. Right. So one is in the D form because it rotates clockwise. The other is L form because it rotates anti-clockwise. D and L form. The equimolar mixture of D and L form, which don't, or rather we should write, which do not rotate the plane polarized light. Please remember why. If we have 50% this and 50% of this, okay. Now, if this is rotating clockwise, this will be rotating anti-clockwise, and they will be compensating each other. They will be canceling each other out. That is why the mixture, if we have 50%, that is not going to rotate the light. So racemic mixture is what? The equimolar mixture of D and L form, which do not rotate the plane polarized light due to external compensation. Due to external compensation is called racemic mixture. It's called racemic mixture. All of you understood what is racemic mixture? Yes or no? Please tell me.
Sir, what does external compensation mean?
External compensation का मतलब the rotation of one molecule is being compensated by other molecule, है ना? So it is external compensation. If the rotation of a molecule is being compensated internally, same ही molecule में if you have two asymmetric carbon, one asymmetric carbon is rotating clockwise, other asymmetric carbon is rotating anti-clockwise, then it is known as internal compensation. Okay. Now we have one molecule that is in the D form and it is compensated by another molecule. So another मतलब external हो गया. Got it? Yes or no? External compensation.
Yes, sir.
Okay. Okay, racemic mixture. Now the point that I've been waiting for. Sn1 gives racemic mixture. Sn1 gives racemic mixture. What is this? Let me tell you guys. Okay. अब यहाँ पे आप लोग please देखिए. Don't write now. लिख लिया सबने तो लिख लीजिए. Otherwise, if you have not done, please stop writing now and listen. We have a carbon atom. It is bonded to halogen as it should be because we are learning haloalkane, haloarene, and it is bonded with, let us say, CH3. And we have here hydrogen atom, and let us say we have here C2H5. Now, asymmetric carbon, this is asymmetric carbon. I hope all of you can see that. Yes or no? Please tell me. Now, all of the four groups are different. Very good. Now, the first step in SN1 is what? It is the cleavage of CX bond and the formation of carbocation. So here we'll be getting, now as soon as the carbocation is formed, carbocation is sp2 hybridized, which will be trigonal planar. This is sp2. Now here I can write the CH3 is here. This hydrogen is here. And we have here C2H5. We have here C2H5. Now, if you remember carbon, carbon is 1s2, 2s2, 2p2. Now we have this type of orbitals. Please don't write, listen. Here we have 2 electrons in the S, 2 electrons in the P. Then excitation will take place, chemical bonding, chapter number 4, class 11. Then all of these take part in bond formation. Take part in hybridization. But when you see the carbocation, it is having a positive charge. It has lost an electron. That is why we will not be having one electron from here. And in hybridization, only these 3 electrons will take place. So we will get sp2 hybridized, and there will be a p orbital which will be vacant. This is pure p. Okay, this is pure p. This all of them sp2, they have this type of structure. 3 hybrid orbitals having this structure, and there will be a vacant p orbital. This is vacant. Now the vacant p orbital is like this. Yes or no? कोई दिक्कत किसी को? About the structure of vacant p orbital in carbocation, yes or no? Please tell me. Yes, any problem, guys? No problem, na? Okay. Let me redraw this in a better way. Carbon. And also I need some space for the p orbitals. We have here vacant p orbital like this. Vacant p orbital like this. And the molecules that we have here is groups are CH3, hydrogen, C2, H5. Now when the nucleophile is there, when the nucleophile will come, with its electron, the nucleophile can either give the electron in this direction or it can do a backward attack like this. Any attack can be done. Yes or no? It can attack from both the sides. Now, if it attacks from both the sides, it will lead to two different types of product. If it attacks from, let me give this green color and show you guys. If it attacks from the red side, if it attacks on the red side, I will get nucleophile first. Okay, the nucleophile will be here, and it will be attached on the carbon atom. This will be CS3, and the hydrogen will be here like this. Okay, and okay, इसको आप ना ऐसे बना लीजिए इसको तो, because I'm showing wedge and dash. I hope you guys know that this is inside the plane, that is outside the plane. This is C2H5. Okay. Now, can you see it is completely inverted the structure? Yes or no? Please tell me. If I have the bonding from the red part, if the attack is done on the, according to the red arrow, we will get this product. But if the attack is done from the green arrow, I will get what product? Carbon bonded to hydrogen as it is, CS3 as it is, and the nucleophile will be here, and C2H5 as it is. Now, can you see that both of these structures are mirror images? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
And both of them will be formed 50-50%. Okay, this will be formed 50%. This will be formed 50%. And that is why this is what in together we will get a mixture which is Racemic mixture. Everything makes sense? Yes or no? Please tell me.
Yes,
If it
sir.
doesn't make sense, let me know now. Now, when the nucleophile attacks and it inverts the configuration, it is known as inversion. This process is known as inversion. The configuration is completely opposite, inversion. Now, when it does not invert, that means it is retained. We have retained the conformation. The configuration is same. The configuration is same. So this is known as retention. Okay. Now in SN1, 50% inversion takes place and 50% retention takes place. Now let us look at what happens in SN2. You write this mechanism here. Done? Done, everyone? Yes or no? Please tell me.
1 minute, sir.
Okay. Done, guys. Nabil Khan, done? Okay. What about others? Done?
Yes, sir.
Okay. Right, next. Stereochemistry of SN2. We have just seen what? Stereochemistry of SN1. Okay. So let me copy this molecule. We're again taking the same molecule here. Okay. Now, in SN2, the reaction happens in one step. That is why I will take the nucleophile. So before
Sir,
that,
could you show
let me
the
remind.
previous one again? Previous.
लिख लीजिए आराम से लिखिए इसको. This is important.
Okay, done, sir.
Done. Okay. So, thoda sa, very little. I want you guys to revise a bit of 11th standard molecular orbital theory. Let me just fetch that up. Not here. Please look at this formation. Pi, sigma overlapping, anti-bonding, and bonding. Look at these structures. याद है सबको? Yes or no? Please tell me. All of you remember this?
Yes, sir.
Yes or no? Yes, a bit of you remember, right? Okay, fine. Let us move to your class now. Okay. Now we have here CX bond. Please remember, what do we have? We have here CX bond. We have carbon and we have halogen. Okay, carbon and halogen. Now carbon will have its sp3 orbital because it is hybrid orbital will take place in bond formation sp3, and halogen will have its p orbital. So p orbital will be a bit lower here because it is going to be more electronegative. We'll get bonding and anti-bonding. Okay, bonding and anti-bonding like this. Obviously, the bonding orbital will have electron. This anti-bonding will have not electron. It will have 0 electron. Okay. Now, let us look at the shape here. We have sp3, which is something like this. And we have p orbital, which is something like this. Now, the bonding molecular orbital will be, the middle lobe will be bigger, and it will have smaller lobes, which are, so if this is plus, plus, and minus, this will be minus. So this plus plus will give me a big blob of orbital in the middle. And let us look at the shape of the anti-bonding molecular orbital. Anti-bonding molecular orbital. This is my BMO. The anti-bonding molecular orbital, it will look something like this. This is my nucleus. This is my nucleus. There will be nothing between these two nucleus. We will have anti-bonding molecular orbital like this. Okay. Now, this anti-bonding molecular orbital is important. What I will show, in the bonding molecular orbital, this blob is important, which is between the nucleuses, which is between the nuclei. And what I will say, in the CX bond, we have carbon and halogen. I will say that this is my blob of electron where we have electrons. Okay, this is my BMO. And in the anti-bonding, we'll say that this is my anti-bonding molecular orbital. Yes or no? Any problem? Any problem? Please tell me yes or no. कोई दिक्कत किसी को?
No, sir.
No, na? All of you remember this? Okay. Now this is my anti-bonding molecular orbital, which is vacant. And this anti-bonding molecular orbital is just opposite in the direction of X. X is in this direction, and in this direction we have ABMO. Now, when the nucleophile is attacking on the carbon atom with CX bond, earlier it was attacking on carbocation. Was carbocation here. So carbocation. Now attacking on the CX bond. Hence, the nucleophile has to attack from backside. And it will give the electron where? Essentially, nucleophile is giving its electron on the anti-bonding molecular orbital. This bonding molecular orbital is breaking up. Okay. So this is what happens in SN. Now, when it is attacking from the backside, what is going to happen? This X will leave, and we will get a nucleophile bonds with carbon from backside. We have CS3 as it is. We have the hydrogen here, and we have the C2H5 here. You can see complete inversion. So what happens in SN1? Inversion takes place in SN1. याद रहेगा सबको? Yes or no? Please tell me. 100% inversion. Clear है सबको? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Please draw this. You will write what is inversion. What is inversion? So inversion of configuration of the reaction in which yes, the reaction in which configuration of product is just opposite to that of reactant. Okay, it is known as inversion. Other term is retention. So what is the retention? The reaction in which the configuration of product is just as that of reactant. Just as that means it is same. Just as that of reactant. The reaction in which configuration is same, retention. Inversion means the reaction in which the configuration of product is opposite to that of reactant. Yeah.
Sir, can you show the diagram also?
Sure. So it is easier to understand this optical isomer at the end of haloalkane halogen. इसलिए आप लोग को अभी पढ़ाया जा रहा. Otherwise, it is a topic of SN1 and SN2. But that time it becomes very overwhelming SN1 and SN2 because you have to remember the nature of reactant, the nature of solvent, and what type of solvent you have to use, and also the reactivity, how it depends on different leaving groups. So it becomes very overwhelming when we add stereochemistry to it, because stereochemistry has its own baggages. Optical isomer, what is plane polarized light, what is nickel prism, what is asymmetric carbon, what is chiral carbon. So all of these baggages are there. That is why this is taught you at the end. Now the chapter is complete. I hope you have written. Yes or no? Please tell me. Yeah, all
Yes,
of you have
sir.
written. Okay. Now
Sir, show
please.
the last two ones, sir. I didn't finish.
तो जब लिख तो आप चुप रहते हो. हम हमेशा बोलते हैं those who have not written they should answer. जिन लोगों ने लिख लिया उनका क्या.
Sir, I didn't finish it.
हाँ रुकी तो आप लिखिए यहाँ पे. Also write this reaction map. ये चाहिए हमको कब? On Thursday I need all of these four. Okay. चलिए, done guys.
1 minute, sir.